All right. Thanks, team. Welcome to Foundations of Artificial Intelligence, powering the new era of innovation. My name is Jason McGinthy, and I'm going to be taking you on a journey of discovery as we walk through the core principles that drive artificial intelligence and how they're shaping the world through technology and innovation. Regardless of your reason for being here today, I'll say this: we should all be eager to understand AI's role in powering the next era of progress. So, a little bit about AI Ready RVA. A little over a year and a half ago, AI Ready RVA came together as a grassroots effort and with a unified mission to cultivate AI literacy in the greater Richmond region. Our mission is to empower the community through awareness, community engagement, education, and advocacy in the field of artificial intelligence, that is, by fostering connections between tech enthusiasts, educators, industry leaders, and curious minds. AI Ready RVA aims to drive innovation, skill development, and economic growth in the region. Yep, a little bit about myself. I'm a senior manager, software engineering at Capital One. I'm also a board of directors member on the AI Ready RVA board. I'm a technology leader with 20 years of experience of delivering solutions that improve customer satisfaction and reduce operational costs. I specialize in partnering with business leaders to create scalable AI solutions, from enhancing fraud detection to customer self-service, of course, creating competitive advantages that deliver sustainable business results. All right, and a plug for our upcoming event hosted by AI Ready RVA. We're calling our launch event The Power of Possibility. It is a party and an expo. We'll have lots of hors d'oeuvres and drinks and good entertainment through exhibitions hosted by various business leaders and companies in the region, as well as a great panel put together, leadership in the region, and we'll be speaking to the audience about their insights into the future of AI. So again, this is on February 19th. So join us for the party at the Dewey Gottwald Center at the Science Museum of Virginia. I'd say events like this are a testament to the power of shared vision and ingenuity, bringing the future of AI to the greater Richmond region for everyone. So we've got a lot of content to get through today. Here's just a listing of some of the main ideas and principles that, hopefully you have some understanding of. If not, I will be able to share all the details that I've amassed over the years. This presentation provides a broad overview of AI's foundational concepts, from machine learning and neural networks to real-world applications, revolutionizing industries. And I'm here to share with you insights into how these intelligent systems are designed, their transformative potential, and the ethical considerations guiding their development. So buckle in. The QR code in the upper right corner is to subscribe to our socials. So please feel free at any time to leverage that. All right, so starting with the basics, artificial intelligence, or AI, involves techniques that equip computers to emulate human behavior, enabling them to learn, make decisions, recognize patterns, solve complex problems in a manner akin to human intelligence. Machine learning is a subset of AI, which uses advanced algorithms to detect patterns in large data sets, allowing machines to learn and adapt. Deep learning is a subset of machine learning, and it uses neural networks for in-depth data processing and analytical tasks. Deep learning leverages multiple layers of artificial neural networks to extract high-level features from raw input data, stimulating the way human brains perceive and understand the world. And finally, we have generative AI, which is a subset of deep learning, or deep learning models, if you will, that generates content like text, images, code based on provided input. We call that inferences. So the models are trained on vast data sets and can detect patterns and create outputs without explicit instruction, using a mix of supervised and unsupervised learning methods. I noticed that there hasn't been any questions coming up in the chat, so that I guess that's a good sign. But if you do have any, then please drop them in. I'll try to pay attention to them as I go. My first question for you, and please use the chat. Can you tell me who first coined the phrase artificial intelligence and when? And then if you know, as a bonus, what's the conference that it was coined at? All right, I'm assuming that people are Googling this question right now and don't have it off the top. That's okay. I didn't have any prizes for you anyway. So I like the term godfather of AI. Dr. John McCarthy coined the phrase in 1956 at the Dartmouth Conference, which is one of the first events that manifested in time over the artificial intelligence timeline of evolution. Of course, one of the first earlier events was when Alan Turing proposed the Turing test, which was about 1950, if I'm not mistaken. And that became a foundational concept for AI. It's still used today. Question will always remain, like, are we advancing the computer systems well enough for them to outsmart us? And of course, 1956, the Dartmouth Conference. In the early 60s, the development of early AI programs like ELIZA, which was a natural language processing computer program, and general problem solver, therapist even, which is, interestingly, if you look up ELIZA today, you can actually still use it online. Not sure which version it's been updated to, but it's still available for practical purposes if you have any. In 1980s, machine learning, concept of machine learning began to take shape, with algorithms capable of learning from and making predictions based on the data. In 1997, IBM's Deep Blue, term for their chess champion winning system that beat the champion Garry Kasparov in chess, which was, showcasing the potential of AI to master complex tasks. So yeah, there's quite a lull in some of the bigger ticket evolutionary advancements in AI. But as we get closer through the decades, you see that the transformation speeds up very quickly. Starting in the 2000s, we leveraged big data and algorithms because of the explosion of big data and improvements in computational power that led to more sophisticated machine learning techniques, including deep learning. And in the 2010s, There's integration of AI into everyday applications like Siri, Alexa, Google Assist, you name it. Also recommendation in systems like Netflix and Amazon, which we all love. Autonomous vehicles, of course. In 2012, you have the AlexNet rise of deep learning, where at the ImageNet competition, AlexNet had a significant breakthrough in deep learning, leading to major advancements in image and speech recognition. In 2014, Google's AlphaGo by the Google DeepMind defeated a human professional Go player, a feat that had previously been thought to be decades away. And in the 2020s, that's when we saw GPTs and large language models as we know them today. Of course, large language models had existed before 2020s, but in the generative space, advancements through the transformer model, if you will, which I'll explain later, OpenAI was able to demonstrate impressive capabilities in natural language understanding and generation. But that's not all. Over the last few years, specifically, the technology has been advancing at an astonishing pace. In 2020, the GPT-3 was released, which is a large language model demonstrating remarkable capabilities. Of course, in 2021, multimodal learning kind of hit the scene with being able to interpret multiple data types like text, image, audio at the same time. 2022, mainstream of success of ChatGPT. I know I remember the day I experimented with that for the first time, the feeling of awe, right? So, of course, ChatGPT transformed human AI interactions and put it on the map again. There's also Stable Diffusion and Midjourney that we shouldn't forget to give credit to, where they were models that became accessible, allowing users to create high quality images from text prompts. In 2023, the growing adoption of AI-powered features in consumer products, virtual assistants, content creation tools, and personalized recommendations. And of late, the exploration of emerging AI applications continues through research in areas like AI-assisted healthcare diagnoses, autonomous vehicles with advanced perception capabilities, and robotics with increased dexterity. These things transcend many of the former milestones by leaps and bounds. I'd also like to take a quote from a recent United Nations conference, reading off from what the Secretary General said. He said, "To be clear, technology is moving very fast, and in the future, it will never move as slowly as it is today." So let that marinate for a second. All right, so what are some of the top uses in your life? I'm going to go ahead and move on and show you what the top uses are in my life, because I don't expect this to be a very engaging platform. I'm just going to present my findings for some of the top use cases. With the explosion of information services, it would be very challenging for us to find what we want without the help of machine learning. So ML, manifested search and recommendation engines all over the world, Amazon, Netflix wouldn't be what they are today without being able to best match to your taste, right? So we have assistants that started to make their way through people's homes in the early 2000s, maybe even earlier. I think I have one in almost every room. There's recommendation engines. There's GPS services. There's facial recognition. You really can't escape it. And then, if you like learning new languages, there's also machine translation. I'm learning Duolingo, or using Duolingo, to learn French right now, and it's quite the experience. And, so many fun features in that system. But of course, there's more. There is gaming like Minecraft. Minecraft uses Gen AI to create endless environments for the players. There's hospitality robots that can check in people at hotel front desks, or deliver their food at the tables. Maybe even mix drinks. Like, I know the first time I saw a robot deliver my food, I was just astonished. There's ad creation, generative services help you make images based on interaction and purchase data. There's early diagnoses, using patient and disease data to predict the likelihood of patients developing a disease. And of course, there's ride-sharing apps that intelligently pick up new rides and allow you to communicate with the driver. All of which are pretty exciting manifestations of these technologies in recent years. Of course, there's business contributing as well. Maybe not so much fun, but what makes the back office run, or even the customer facing experiences even more capable. You got your content creation, where it'll help you automate tasks and generate ideas. Anybody seen the latest in ChatGPT's beta? It's running those AI agents. That's pretty cool stuff. Your personal assistants, like chatbots, can help organize schedules, real-time support, streamlining daily life. You got your customer service, where AI-driven chatbots and virtual assistants, powered by machine learning, they can handle inquiries and transactions efficiently. Your risk management, to manage various financial risks, analyzing large data sets, identifying risk factors more effectively. Portfolio management. When I think of that one, I think of robo advisors. Being able to use algorithms to plan any sort of investment strategies. Predictive analytics, also, forecasting future trends, and your document analysis and compliance type things for parsing through massive amounts of data and analyzing to ensure that you remain compliant and follow suit with the legal controls in place. So these applications demonstrate how machine learning is transforming industries, making them more efficient, secure, and customer focused. All right, so now what's some of the magic behind this technology? This is where we're getting into a little bit more of the detail. Machine learning as the foundation of this presentation and many of the technologies that I'm sharing with you today. Is a fascinating branch of artificial intelligence. It enables computers to, as I said before, learn from data and improve the performance over time without explicit programming, which is why it's considered magical to some folks. Of course, machine learning mimics human learning processes as well. At a high level, you would use an algorithm and some example data to train the model. Then you integrate your model into the application to generate inferences, in real time and at scale. At scale is like an industry term for ensuring that your target audience can access the system when it's in production, depending on how many people you expect to have using it. So in a production environment, a model typically learns from millions of examples, data items, and produces inferences in milliseconds. It's important that the inferences are produced quickly because your users don't want to wait around for the results. Now, double clicking on this process, this flywheel, if you will. To train the model, you need the example data. The type of data that you need depends on business problem that you want to solve and the inferences that you want the model to generate. So, for example, suppose that you want to create a model to predict a number given an input, such as the ones in the upper right corner there. So predict the number given the input, like what is this handwritten number supposed to indicate? Teaching a computer to be able to do that. You have to provide it a lot of examples and train it to do that. So you're fetching the data, which you might have in-house examples of data repositories. You might use data sets, a lot of varying handwritten material to stay on this example. You may have 100 different ways to write a 1, 300 different ways to write a 2, and so on and so forth. And then the next step is to clean the data. So you need to ensure that you're improving the model training process by inspecting the data, making sure it is as clean. I'll have to vary from this analogy a second and say one example would be if you had data coming in from some sort of database that had the United States listed as one of the field entries and then US or USA in another, and to the human, we know that means the same thing, but to a computer, you got to make sure it's consistent so the computer can follow along with the logic and its interpretation, its meaning. And then finally, you prepare that or transform the data to improve the performance. You might need to perform additional data transformations. Data transformations being, let's say you have a location field that encompasses a city and a state, but you want more targeted information. So you leverage geographic latitude, longitude to tell the computer exactly where that is. So you're taking two various attributes and merging it into one. By combining those attributes, you get a new attribute, and depending on the purpose of that attribute, it might make the model better. All right, so here we get into training the model, which includes both training and evaluating. And I think about training the model, I think algorithms, right? Or pre-trained base models. The algorithm you choose depends on a number of factors, such as the problem you're trying to solve, like I said before, the type and size of the data, additional computational time, the number of features and observations. And speaking of compute, they're resources like anything else. And depending on the size of your training data set and how quickly you need the results, you can use resources ranging from single general purpose instances to distributed clusters, like leveraging GPU instances. If you follow NVIDIA, that's kind of what their specialty is developing highly performant GPUs and various other hardware devices to build out AI infrastructure. GPU stands for graphical processing unit, in case you are curious, as opposed to CPU, which, as I get nerdy and say this, is the central processing unit. CPUs are more generic processing units, and GPUs parallelize the processing capabilities, and that's why they're so much more powerful for running the attention mechanism requirements of AI models, which I'll get into in a little bit. So evaluating your model, after you've trained the model, you evaluate it and determine whether the accuracy of the inferences is acceptable. You send the model the held out observations for which you know the target values, and then you compare the predictions returned by the ML model against the known target value. And finally, you compute the summary metric that tells you how well the predicted value and the true values match. Yeah. Anybody would like to throw a question out there? Comments? All for it? If not, I'm going to continue to proceed. What is Go? I'm not sure I understand the question. What is Go? Is that a reference to a language or AlphaGo? Are we able to restate that? Oh, there's a few comments in here. Okay. That's cool. All right, thanks, Will, for jumping in. I don't think there's anything in there that. Yes. Oh, Go is in the. Oh, okay. We're going back to that. I see. Yes, the game. Thank you. Where are we here? We're in deploying the model. So I was actually looking at the wrong tab for these chats, and it caught me off guard when I saw something flash up on the screen. My apologies. I'll try to track the right chat, the right chat thread now. All right. So little known fact: 90% of all the ML models don't actually make it to production. There's a lot of experimentation. Not all models are. Most models aren't really built for production environments, and so when you work through the iterative process of developing the model and getting it right, you then have to consider scalability, budget, data privacy, all of those things, cost, security, integration capabilities. Yeah, so I'll try not to go off the cuff there too much, but you should deploy your model independently, decoupling it from the application code so that you can make adjustments to the model without having to deploy the application, or vice versa. I'd call it a microservice thing, but maybe there's more to it, and I don't want to misquote the intention there. But finally, you need to create one or many endpoints for your application to call the model, and that would be depending on your hosting strategy. Largely speaking, there would be accessible infrastructure in the cloud is probably the primary method of deploying such applications, which I'll talk a bit more about later. See more discussion coming in here. Thanks, Will. All right, to track your model through the metrics, you need to consider such things as like accuracy and drift. You should monitor your model through well-known evaluation standards, like precision and F1 scores, things that I will not be getting into right now. Along with model effectiveness, you should also include visibility into the demand and or changes in the workload to ensure the scaling strategy is effective as well. Um, a lot of the concepts I just threw out there kind of follow into um, the responsibilities of a machine learning engineer or ML ops. Um, but also, a lot of companies are training their software engineers to be able to take up the ML ops roles as well. I've got a lot to say about that, but not personally from my own company's perspective. If anybody has any questions about those various roles, their intricacies, and how they relate. Um, but yeah, it takes data scientists, um, analysts, product managers to kind of come up with the best experiences that we want to experiment with, and then to get it to production, you really need a team that's got the background of how to host such systems and ensure that the model will scale, like I said before, and some somewhere between those that put it in production and those that developed it need to monitor it for drift, which, as I didn't actually explain what drift was, but it's where you're evaluating the model over time and determining whether or not it's still performing at the level that you would expect through your evaluation process. So yeah, they look at those key evaluation metrics and say, is this thing doing what we want it to do at the threshold that we expect it to? As long as it doesn't drop below the threshold, then typically it's okay. And I actually have a little bit more to say about that from this slide's perspective. So machine learning is a continuous cycle, right? Flywheel. After deploying the model, you monitor the inferences and you collect the ground truth, the data that is accurate and reliable, that you kind of put out there to say, this is the benchmark. This is what we train the model to be able to do. And as long as the model is doing this benchmark and we don't see drift, then we're good, right? Then you increase the accuracy of your inferences by you know, doing more iterations of the training. You take the newly collected ground truth, say, okay, this is my new bar. We're setting the bar, right? Expectation of this model, and I'm going to retrain the model with that new data set. I'm going to get provide it more and more examples. And as more examples are becoming available, let's say your customers start using the technology in ways that you hadn't expected, and they're giving you new data on that, maybe you want to revamp it a little bit and allow it to do more of those things more effectively, and so like you would go through that process, the cycle of retraining it. But again, after deploying the model, when do you stop, right? Like, is it forever and ever? I'd say mostly no, but sometimes yes, right? It's in practice, the training of the machine learning model often doesn't completely stop, but instead it continues iteratively as long as new data is available and useful. So when you think about software applications going from conception to infancy to maturity to finding some space after maturity to either reinventing itself or being deprecated, at some point it doesn't make sense to continue training the model, right? Maybe there's some other things while you're in a mature state, or developing new features somewhere else that doesn't need it. Maybe the model's performance on the validation data plateaus, and indicating further training would yield diminishing returns, or because it's computationally super expensive to do, depending on how much and how often. You may want to consider, these resource intensive processes to um, determine whether or not you're going to get your return on your investment if you keep doing it. Accuracy, of course, like I said before, um, and if you don't see any significant drift, then why not leave well enough alone? At least that's what I like to say. So while you may take a break from active retraining, continual monitoring and periodic evaluations are essential while it's out there in the wild doing its thing. I'm not going to read this off to you. I'm just going to just kind of cut through it pretty quickly. I'm sure many of these are familiar. You got your supervised learning that people label your data for you. Your unsupervised learning where there is no labeling. You have your semi-supervised learning where there's both. It's kind of a middle ground, of course, and usually a little bit of supervised and a lot of unsupervised goes a long way. Reinforcement learning, this is really where the cool stuff kicks in, I think. Applying to robotics, gaming, navigation. What are some samples of drift I've observed? Well, that's a good question. I can't talk about the work that I do at my company, unfortunately, but I'll give you an example of that you might want to consider for drift. So when you're evaluating how effective your model is in terms of being able to predict what the customer wants. So I talked about this before. You have some sort of prediction mechanism. Let's say it's predicting what what Netflix, right? What Netflix movie or show should pop up on this customer screen. And if Netflix starts getting a flood of feedback from their customers saying this is garbage, I didn't want to see this on my screen, they're going to pick up on that data pretty quickly and try to investigate it and say, okay, something went wrong here. We need to adjust this because we're creating a dissatisfactory result for our customers. So hope that helps. So reinforcement learning is really yeah, it's basically on a process of rewarding or what's the word? Kind of drawing a blank. Yeah, so it's a reward and or negative. What's the word? I can't think of it right now. But the idea is that you're teaching the computer based on the reward system that they should be doing more of that. Oh, rewarded punishment. Sorry, I don't know why I can't think of the word punishment, but if you deduct the reward system, then the computer will acknowledge that as a bad behavior and do something different. Once it identifies what the good behaviors are, it becomes more rewarded and say, oh, I want to do more of that because that is my goal. That's my entire existence goal. And so that's why it works really well with robots, is because they're rewarded for their good behavior and they can learn from it. Bonus term, not an algorithm per se, but ensemble learning is really cool because it puts together multiple models and it strengthens the outcome. So yeah, the idea is that by using a variety of models, the strengths of each can be leveraged while their weaknesses can also be minimized. All right. Machine learning versus deep learning. This is some cool stuff. Of course, machine learning uses a lot of data points, but deep learning uses millions upon sometimes billions of data points across large amounts of data to perform, I would say, better than traditional machine learning models typically. Of course, some machine learning models are really, really good at what they do. So, why over-engineer something when it's really, really good at that, and that's all you need it for. Machine learning models are basically algorithms that can include simpler linear models and decision trees, cluster techniques, that sort of thing. And as deep learning models go, they deal specifically with neural networks and multiple layers. The more layers, the deeper the neural network, hence the term deep. These models attempt to mimic the human brain by creating artificial neural networks capable of learning complex patterns. And they're particularly powerful for tasks like image and speech recognition. The picture up here is by design. You feed it a bunch of data, and it goes through various layers and outputs on the other end, an inference or a prediction. Thank you. Cool graphic, yes, I love it. Some of the differences are deep learning models are generally more complex. They also, because of their need for more computational power, like GPUs, for their training process, they're more expensive to run. Machine learning models, inversely, are simpler typically and a little easier to interpret. And I think interpretation is really important for certain companies. And being able to leverage these technologies, you've got to be able to explain what it's doing and why in many cases. Deep learning is often reserved for tasks with high complexity and particularly large scale image, text, and audio processing as well. So I mentioned a little bit about neural networks, and I wanted to share with you the biological inspiration of that. So as far as deep learning goes, the concept of neural networks is basically expressing the relationship between the brain and the deep learning architectures. You want to impress somebody, use some of this and say, oh, we have a deep architecture here, and talk with them about the significance of that in the sophistication of your product. That'll make you look like an expert. There's an inspirational and a functional component to neural networks. So it's loosely inspired by the actual human brain, starting with the neuron, where the basic unit of the deep learning system is the artificial neuron. And that's inspired by a biological neuron in the human brain, which both systems have the units receive input. The units are the neurons. They receive the inputs and process these inputs and pass on their output to other neurons. And just as there's in the brain different regions for processing different types of information like vision and knowledge, vision and language, deep learning architectures are composed of layers, like I said before, each layer typically specializing in recognizing certain types of patterns. And so when you double click on, particularly through neural networks, how certain processes occur, like back propagation, which is a technical term for being able to learn from its training mechanisms. I'll kind of leave it at that because it's fairly complex visuals that I didn't come up with for this presentation would help there as well. And the adjustment of weights is a simplified abstraction of how we believe learning happens in the brain, which is, synaptic plasticity, which is a lot to think about. But consider the fact that scientists don't know everything about the human brain, and so they're abstracting what they do know and building neural networks to try and leverage the power of the brain. So both the human brain and the neural networks process information in a parallel manner, allowing for the efficient handling of complex and high dimensional data. All right. Now, I talked about attention mechanisms very briefly before. This is where it kind of all began with the paper called Attention is All You Need. I think it's a fairly easy read in terms of research papers and how they go and the length of this one, and what you'll get out of it is massive. So I would invest half an hour in reading it if I were you, if you wanted to learn more about these things. But nonetheless, it's a groundbreaking paper in the field of natural language processing that introduced a new way of processing data called the transformer model. Yes, highly recommended. Good. I'll have to look at that one. So imagine you're trying to understand a complex book, and instead of reading it from start to finish, you focus on the most important parts that give you the gist of the story. This is similar to how a transformer works. Before this type of transformer model existed, computers had to process information in order, much like reading a book from start to finish, or left to right, or various languages, right to left, top to bottom. I don't know all the languages, but this is slow and inefficient, especially for understanding languages where sometimes you need to know the end of a sentence to understand the beginning, right? Like I go back to my French lessons in Duolingo and find it challenging to read because sometimes you can't understand exactly what it means until you look ahead. It's frustrating for my English native speaking brain. So the transformer model, of course, it changed the concept of machines interpreting information by using something called attention mechanisms. Think of attention mechanisms as like the computer's ability to be able to look at every word in the sentence at the same time and decide which words are the most important, which, of course, those most important words, it would leverage its context and its meaning. By doing this, it can process and understand language much more efficiently. And that's why, feeding your standard chat application these days an entire document and it being able to parse through that and answer a simple question is baseline for it these days. So that idea is incredibly influential, and because significantly improved how machines understand and generate human language, we can now teach a computer to read and comprehend books, articles, any text much faster and much more efficiently, effectively before, opening up for advancements like translation services, the chatbots you see today, and much more. So again, this is a cornerstone document, so I wanted to give it some credit. Now I want to double click on large language model and generative AI specifically because I think early on in discovery here, people have a tendency of not really knowing the differences. I'll start with generative AI because that's the umbrella term, which refers to artificial intelligence models that have the capability to generate content such as text, code, images, you name it, right? Video, music. Music's so cool. I mean, in general and generatively speaking, just fascinating. It leverages the power of machine learning and neural networks, large language models to create novel content on the fly. Again, mimicking human creativity. Yep. Thank you. Probably need to update that timeline, publish date. So large language models are now a type of generative AI. Again, we're referring to large language models as the latest edition of them. I think of models like BERT, BART, other various Elmo, things like that, that served their purpose in their time. Maybe they even serve purposes now, but those aren't the types of large language models when people are talking about what LLMs are. Think of LLMs these days as your, GPTs through OpenAI, Claude through Anthropic, Llama, which you didn't know, Llama uses the acronym LLM in the word Llama, by Meta, Gemini, Google, et cetera, et cetera. There's so many I can't even list them anymore. So yeah, that's basically the difference. Now, I'll talk to you a little bit about large language models in the first place. I think this is where the insights really start coming alive for people. Enthusiasts, professionals, you name it, all should understand this at some level. So an LLM, right? Imagine you have a huge library filled with all the books, articles, websites you can ever imagine. And say you have a question, any question, or maybe you need help writing a story. Instead of reading all those books yourself to answer the question or get ideas, you ask this super smart robot that has read everything in that library. I mean, everything. And it's really good at understanding your question and can give you a helpful answer or even make something up on the fly. That robot is the large language model. It's the software application that calls the language model, requests the inference based on that query that you provided it. So LLMs are computer programs trained to understand and generate human-like text by analyzing a massive amount of written material. They learn patterns, how words and sentences are put together, and how they can predict what words might come next in the sentence, which interestingly, if you do like the research on how these things actually output their inferences, it is basically a word at a time. And that's why the output of a text chatbot shows a string of words as it's producing them. Well, that's in real time how quickly the model is producing them. More computational resources, the faster you'll see that produce the results. But nonetheless, it is determining, based on this query, I need to say this word first, and then based on the prediction results of that word, I'm going to say this next word is the most likely predicted word to say next. And that's how it strings along sentences. And when it gets to the end, where it believes that it answered your question, it stops. Pretty cool stuff. All right, so that's where I'll end it with large language models. Now I'd like to take you up a notch or down a bit, depending on how you look at this, and discuss the differences between LLMs and agents. So large language models are a type of generative AI, as we talked about, trained on text to produce textual content. AI agents are designed to perform specific tasks, make decisions, and often incorporate multiple AI technologies to achieve their goals. So in essence, AI agents use LLMs alongside other AI technologies to perform broader and more complex tasks autonomously. So we don't forget that, right? You're setting it, and it's going to go and make some decisions to perform its task and achieve its goal. It's really it in a nutshell. But there's so much more to it. Agents are systems or programs capable of autonomously performing these tasks on behalf of users or other systems, agent-to-agent communications. They leverage advanced natural language processing techniques like LLMs to comprehend and respond to the user step by step. Some of the more advanced ones will check their facts before they assume things by what the user asked. I'll get into some of the steps in a minute. These agents can also perform a wide range of functions, including decision making, problem solving, interacting with external environments, and executing actions. They're deployed in various applications through software design, IT automation, code generation tools, and of course, conversational assistants like the latest ChatGPT beta. Just checking up on the chat there. Looking good. Oh, thanks for the llama. It's very nice. Very nice of you to add that in there. So here we have a little bit more about AI agents. Now, I'm not going to get too far into this because I think we have a presentation coming up in a couple of months. Sorry, I don't have the date. Maybe Will can drop it in. But we have a scheduled presentation, which I think you all should check out if you're interested in AI agents and the inner workings. So they function through two main guidelines, one reasoning and the other tool calling within the boundaries of the generative AI use cases. So reasoning is your planning and evaluation, where agents plan, evaluate progress, and adapt strategies to solve the complex problems. They analyze multiple steps of the task. They adjust their strategies based on outcomes. And of course, they make their decisions dynamically, which is pretty incredible. And then on the right side, you have your tool calling, which AI agents would execute functions. Simply put, a function can be a simple executable of some sort or API or whatever. It's doing something and interacting with the data that's been provided, usually external sources, right? Like you say, here's a link, I want you to, write me a summary that I can use in a book report and an executive summary for my my work, and I want you to be as professional as possible. So it's going to go through and leverage that internet search as a function, grab the information, and then look at external data for all the things it knows about book reports and professional executive summaries, and produce two varying forms of the same outcome. Yes, thank you very much for putting that out there. And then you have the intersection, right? Intersection of tool calling and reasoning is where your enhanced problem solving occurs, where it combines the tool calling and with the reasoning, and allows the AI agents to tackle multiple step problems more effectively. AI agents can now not only access and use the tools, but also reason through tasks to process more accurate and sophisticated solutions. All right, and so this is probably one of the biggest things that's going to be coming out in various news sites and organizations. It's because they're able to leverage these concepts to streamline workflows. It's all fun and games to get ChatGPT to do your homework for you, but if you can take basic tasks that a data entry operator, or gosh, I hope none of your jobs are on the line here in the future, but there's a lot of tasks that people do that these agents are going to be able to consume. So companies, as companies do, will be looking for ways to make their workforce more efficient. So by leveraging these agents to make your own job better, if you see the productivity gains for yourself, perhaps you'll be able to boost not only your job performance with these agents, but also boost the company and get rewarded for it. There's a silver lining to everything. Now, I'll say there are three concepts, and this is the last bit I talk about on agents. Single turn, multi-turn, or multi-step, and then multi-turn. Single turn is where an agent can fill a user's request, making one function call. And it's typically pretty straightforward. It's self-contained and state agnostic. Doesn't really rely on any prior context. And then you have the multi-step, where your interactions require the agent to execute multiple internal functions or function calls to address a single user request. This process reflects the assistant's ability to proactively plan and gather information to deliver the comprehensive response. The user only interacts with the model once, right? And that's at the very beginning, and then the agent does the rest. It interacts basically with itself and all of its given guidelines and tools and reasoning to have back and forth discussion until it completes the task. Now, finally, there's multi-turn, where interactions involve an extended exchange between the user and the assistant or agent, consisting of multiple conversational turns. Each turn may involve several steps, and the agent must retain and utilize the contextual information from prior steps in possibly prior exchanges to handle the follow-up queries effectively. The user will interact with the modal. Modal is another term for the interface, but the model multiple times throughout the process. All right. So that's single turn versus multi-turn and how it leverages the intelligence of reasoning and tool calling to complete multiple steps autonomously. All right, moving on, taking it back up to high level. What do we do when we want to advance responsible AI? We start with data-driven decision making. Um, your data is the most important asset to your company. The idea of coming up with the right problems to solve and understanding the user's needs to solve them, all that's data driven or should be. And that sort of decision making process enhances the accuracy and efficiency and effectiveness of your applications. Then you have cloud first, which is not the only way to do it, but considering leveraging the cloud gives you latest and greatest tools and innovations, flexibility, and I'm going to talk a little bit about some of those things in a minute. Why not, right? Modern tech stacks, it's super important that you're not introducing advanced applications into super legacy systems that can't handle it. So in order to leverage the full potential of AI, you need to maintain and maintain your competitiveness. You need to adapt to the changing landscape, and that includes updating your technology stack. Of course, the modern data ecosystem, mainly data transformation, makes it more suitable for modeling. It can improve the accuracy and efficiency of the models. It's essential for handling types or various types of data in machine learning. To be able to centralize all of your data and I would say govern it properly, put well-managed controls around it, label it, use it effectively, put in access controls. All of that is really important to being able to build the right ecosystem for your AI technologies. Platforms, big tech companies are huge on centralized platforms, and of course, every company centralizes processes. They play, the platforms plays a crucial role in successful implementation and scaling of these, enterprise-based models, and it offers a unified, secure, efficient environment for data management, model development, and integration into the business processes. And then there's focusing on risk management, which I've mentioned a number of times throughout this presentation. As AI advances, it is essential to ensure that the benefits of these technologies are realized safely and sustainably. It's not a choice, right? Your business depends on it. Your customers depend on it. And finally, talent. As the technologies continue to transform industries, you got to invest in the engineering and the data science talent, as well as the supportive job families like product and data analysts, business analysts. Sorry, I know I'm leaving off a few, but they need to also stay up to date with the trends so that they can drive the innovation, manage your risks, ensure your compliance, and deliver superior customer experiences. This focus is not only enhances the intuition of your competitive position, but also it ensures the long-term sustainability and success for your company in the digital age. All right. So I said I would talk about the cloud. Here's all of the reasons why it's important to use the cloud. Whether you believe me or not, this is not unique. I've even quoted these things down below. So your cloud services can easily scale all the resources that are needed to handle the large data sets, your high computational demands, and all the tasks that you can ever imagine deploying. You also pay as you go. You only pay for what you use, that is. Of course, it can be extremely expensive if you are leaving not hardware, but the virtual environments up and running when they're not in use, or you're not taking advantage of the scaling processes. Your cloud provider also offers the latest in SOTA, or state-of-the-art hardware, including specialized GPUs, which might be hard to come across if you're looking for a lot of them, TPUs that are optimized for machine learning and deep learning. Your cloud platforms allow you to access the applications from anywhere. So they're flexible and accessible to a range of services from anywhere in the world, with some exceptions, of course, when there are economic disputes amongst countries. I digress. Anyway, you've got the ability to manage large data sets using their storage and backup and recovery processes. You've got your security capabilities where you have a shared security model, which is super important to understand if you're deploying to the cloud, because you can get into a lot of trouble not holding up your end of the bargain, just by the way. So pay attention to your security when you're deploying on somebody else's infrastructure. Rapid prototyping, the cloud enables quick setup and deployment. Instead of weeks or months building out your server infrastructure in your own data center, procuring all of that, you can have it in hours, minutes, if you have templates already set up at a click of a button. Excuse me. Global reach, I think we understand that one already. Automatic updates. Most cloud providers want to make it really, really easy for you to use their services. So anything they can commoditize or standardize or keep secure on your behalf, they will. So being able to take advantage of those automated updates is extremely important. You don't have to go to your operating system vendor of choice and download something anymore, right? You schedule your maintenance window for midnight to 2 a.m. and let it run. Takes a lot of the heavy lifting off of your engineering staff. But in general, your cloud platforms offer a rich ecosystem of AI and machine learning services it's only going to get better and better. It's really, really hard to compete with this type of innovation. So yeah, there's so many benefits, and it's essential to consider the factors like data privacy, regulatory compliance, specific needs of your application when deciding whether or not to use cloud services. That's why I would say go back to the previous slide and select the right talent. All right. Now there's some challenges. I think this slide bores me a little bit, but I think it's super important. I'm gonna have to upgrade it sometime in the future. You have uh, an ecosystem of likely problems and risks. So each of these challenges must be considered carefully to ensure that you're properly using your machine learning capabilities. You have large amounts of high quality data being passed to and from over certain networks. You need to gather and clean and ensure the quality of the data, which is very challenging. Data scientists, very expensive data scientists, spend a lot of time in that realm. Your machine learning models can amplify biases, leading to unfair outcomes, which I know is a concern near and dear to AI Ready RVA, and we'll be sharing a lot more of our opinions about that in the future, given that certain regulations are changing hour by hour now. Many machine learning models, especially deep learning models, are also very complex and lack transparency. So going back to simplicity when possible, or complexity when necessary. The more abstraction a model does, or reasoning and uh, autonomy you give it, the less you'll be able to predict what it's going to do and or understand how it did it. You've got training machine learning models, not a trivial task, particularly deep learning models where it requires significant computational resources, and it can become very expensive and, as we know, energy intensive. They're vulnerable to attacks, such as adversarial attacks, inadvertently exposing sensitive data used in training. So it's a word of warning: don't give these don't give these models that are on the free market or even paid services your data, your sensitive data, unless you know that it can be locked down and not leveraged for training and not reused or sold on the market. They obviously need regular updating and maintenance, which takes time. And developing, maintaining these models is, takes a lot of expertise. So the talent gap is significant. All right. So when you think about AI technologies, do you want to build, buy, or partner? A couple of questions laid out on the board here. If your business has unique processes or needs that cannot be adequately addressed, you might want to custom build an application. You also might want to do that if you have a significant competitive advantage in your industry, or some nuanced workflows that aren't built easily by off-the-shelf vendors. If you want to get something launched quickly and you know that a partnership would work, then and you know that they will work with you on developing new features and things like that, that's great. Maybe buying or partnering would be the right solution for you. But ultimately, the decision should align with your business strategy, your operational needs, and the resource availability that you have at your fingertips. Because sometimes a hybrid approach combining off-the-shelf elements with custom-built components can offer a balanced solution. All right. Now I'll leave you here with a final informational slide about some predictions for 2025. And if you follow AI news, these aren't going to be shocking to you whatsoever. But multimodal to multimodal, where text and images and sound and video is runs off of each other. Your agentic AI, as I said before, is all the rage. Open source. If you don't understand the significance of open source, feel free to follow some of the big advocates of how Meta's Llama models and other open source models that are hosted in Hugging Face are the only thing people use because of the various concerns with, like I said before, data privacy, as well as transparency. One good thing about open source is that how the model is trained, the weights, basically getting back to the layers of your deep learning architecture is what is this thing actually doing? And I think that's really important to ensure that the technology is not getting into the wrong hands or doing the wrong thing. You can't stop that, but there's a lot more nefarious things you can do with the technology when no one really knows what you're doing with it, right? I'm preaching. Sorry about that. If anybody works for OpenAI. Increased attention to regulatory frameworks. Yes, absolutely. Edge AI, computational capabilities, bringing the AI to the device. Small language models, fine-tuning high quality, medium-sized data sets and getting, quality outcomes. A lot less expensive to do if they work just as well. Faster, cheaper computing, of course. And finally, if we see this in the near future or don't see this in the near future, I'd be surprised, but infinite memory for these AI models will being able to draw from a pool of infinite data. These systems will be able to provide highly accurate and contextually relevant advice based on comprehensive understanding of all available knowledge, which will make it that much more powerful, to say the least. All right, I'm sure there's some other predictions out there. If anybody wants to throw them in chat, that'd be great. I'd love to see what your thoughts are. Okay, so this is our call to action, or one of them, one of the many that we have as a nonprofit organization. We want you to follow us on our various channels so that we can connect with you, provide you our insights, and help you leverage the community at large as we make Richmond an AI hub. And of course, the power of possibility. Once again, it is our flagship launch party, if you will. We'll have lots of companies in the expo segment talking with you all about their feats, as well as any other innovations that they feel like would be good to have open dialogue with potential customers. So if you're a potential expo signee, then get on board. We've got a few more places open for you to offer your services to the community throughout the evening of February 19th. And again, that's at the Dewey Gottwald Center, the Science Museum, Virginia. It is a innovative, very beautiful room that hosts many get-togethers like this, and ours, I expect, will be exceptional. I'm also very excited about the lineup for our panel. We will have a leadership panel facilitated by one of our own, talking with industry leaders from across the state of Virginia, sharing their insights. I know everybody will get something out of that, and being able to connect with these folks as well. All right, and finally, we love feedback. So if you could, please complete our survey. Tell us how we did today, and how we can make things better for future events and whatnot. I got an absolutely from Liz. Thank you. Not sure what that was for, but I'll take it. All right, any more questions? Let's see, I'm gonna drop off this screen. Sit here awkwardly for a moment till I see anything coming through on the chat. Wow, I took up all of the hour and a half. That's amazing. Thank you, Charles and Catherine. The survey link doesn't work. Okay. It might be a dead link. It was posted in here a while back. Thank you, Gloria. Thank you, Ralph, and all of the LinkedIn folks. Appreciate that. We will update the link and get it back out to you. Thank you, AI Ready. All right, and feel free to connect with me on LinkedIn. I love meeting new people. And if you see anything in here that interests you, that you want to learn more about, I'm happy to share all of the resources that I've ever come across that I can think of that would help you, right, in your journey. That's what we're here for, right? Literacy and education and community engagement. So that's not lip service. So reach out. Thank you, Janine. Yay. Thank you, Liz. All right. Will, is there anything else? We good here? All right. Well, see you all around. Thank you for your time this evening, and hopefully catch you and meet you in person at the Power of Possibility. Have a good night, everyone.